Geometry, Chapter 1, Section 7, Circles. A circle is the set of all points in a plane at a given distance from a given point. So in our diagram here, what it's referring to is everything here is a set of points. So there's a ton of points along this line. So you got a point here, here, and so forth. So you got all these points. Now all of these points are a given distance from the center point P. And then this circle is referred to by its center point. So this is called circle P. The radius is a length of a line segment that connects the center of the circle to the point on the circle. So that's the radius. The radius is called by the center point and a point that's on the circle, so AD. And every single radius that you draw has the same length. So every single radius that we draw here is congruent to another radius of the same circle. The diameter is the length of a line segment that connects a point on the circle to another point on the circle, being collinear with the center of the circle. So the line connects one side of the circle to the other side of the circle, and it goes through the center. Now, every single diameter that we draw on this circle will be congruent. And also, a diameter is twice the length of a radius. An arc and the semicircle. An arc of a circle is 2 points on the circle and a continuous part of the circle between 2 points. In other words, this is an arc. A semicircle is an arc whose endpoints are the endpoints of a diameter. So you can see this is the diameter, and what we already highlighted is the semicircle. Now, the way an arc is written, you notice here that it doesn't have a solid line above it, it has a curved line above it. So it's arc CD. A chord. A chord is a line segment that connects a point on the circle with another point on the circle. So it just goes from one side to the other. It doesn't have to go through the center, but a chord can. It just connects one side to the other. This would be ED, line segment ED here. A minor and a major arc. A minor arc is an arc whose measure is less than 180 degrees. So this is a minor arc. A major arc is an arc whose measure is more than 180 degrees. So you can see the major arc is in green. Now you'll notice I have two names here, arc ED. Arc ED, that is our minor arc that you saw here. EFD, notice it has 3 letters. The reason we had to use 3 letters is because we had to use a third letter to help determine the direction that our arc is going in. So we start at E, going through F, going to D. That is our major arc. The tangent. A tangent is a line who intersects a circle at a single point. So the line is touching this circle at a single point. And in this particular case, it's touching the circle at point D. So one interesting thing about this is the fact that a tangent will be perpendicular to the radius drawn to the intersecting point, in this case D. Okay, so let's go ahead and let's work through and identify a bunch of these radius, diameter, chord, and so forth based on this diagram. So based on this diagram, we actually have 3 possible radiuses. AH, AR, and then AS. Those are all radius. Okay, diameter, we have one diameter, SR. Chord, we also have one chord. It's also SR. Now, if I drew a line connecting R and P, that also would be a chord. Tangent, TH. Remember, a tangent is also a line, so I'm going to draw a line above it. Semicircle, SR. It's an arc. Minor arc. I'm going to do RP as my minor arc, but I have other minor arcs. If you look at this, you know, RP is a minor arc. It's less than 90. I also could do, sorry, less than 180. RH, I also could do HS. All of those are minor arcs. So RP, RH, and then HS. And major arc, there's a number of possible major arcs in here as well. Remember, a major arc is more than 180 degrees. I'm going to go ahead and do this as my major arc. There are multiple in there, but that's the one I'm going to write down here. So R, P, H. I also could have written it as R, S, H. Both of those refer to the same arc. Now let's do a little bit of algebra review. Let's simplify this equation. So we've got 2x squared y cubed times 3x to the 5th y to the 7th. So that times, I actually do multiply. So I do 2 times 3 and I get 6. X squared times x to the 5th, well, if we remember what we're actually working with, x squared is really x times x. X to the 5th is x times x times x times x times x. So I'm multiplying those. So I actually have a total of 7 x's here. So I end up with x to the 7th. I also can think of that as, so x squared times x to the 5th, I can think of that as x 2 plus 5. So with that thought process, that makes solving for y a little bit easier. So y cubed times y to the 7th, I can think of that as y 3 plus 7, and I get y to the 10th. And there's my answer. 6x to the 7th, y to the 10th. All right, so let's look at a little bit more complicated one. So negative 4x cubed, y cubed, z to the negative 3 times 3x cubed, y to the negative 2, z cubed. Okay, so let's start. Negative 4 times 3, negative 12. X cubed times x cubed, so that's x 3 to the 3, so that's x to the 6. Y cubed minus 2, so it's y to the 1. I'm just going to write that as y. And then z negative 3, sorry, that should be a plus. Z to the negative 3 plus 3. So that's z to the 0. Well, anything to the 0th power is really 1. So I don't even need to write that. So my answer is negative 12 x to the 6th y. And that is the end of this lesson.